Hi, welcome to the video, Building an Interactive Object Tracker using the CAMShift algorithm. Previously, we performed object tracking using background subtraction. Color space-based tracking allows us to track colored objects, but we have to define the color first. This seems restrictive. Let us see how we can select an object in a live video and then have a tracker that can track it. This is where the CAMShift algorithm, which stands for Continuously Adaptive Mean Shift, becomes relevant. This is basically an adaptive version of the mean shift algorithm. If you want to explore it further, you can check out this link. Let us see how to build a tracker. Create a new Python file and import these packages. Next, define a class to handle all the functionality related to object tracking. In this, first we initialize the video capture object. Then we capture the current frame with this line of code. Set the scaling factor and resize the frame. Then create a window to display the output. Set the mouse callback function to take input from the mouse. And initialize variables to track the rectangular selection with these lines. After that, define a function to track the mouse events. Here, we first convert x and y coordinates into 16-bit NumPy integers. When the left button on the mouse is down, it indicates that the user has started drawing a rectangle. If the user is currently dragging the mouse to set the size of the rectangular selection, track the width and height. Then set the starting x and y coordinates of the rectangle. And get the maximum and minimum values of the coordinates to make it agnostic to the direction in which you drag the mouse to draw the rectangle. After that, reset the selection variable. Then finalize the rectangular selection. If the selection is done, set the flag that indicates that we should start tracking the object within the rectangular region. And then define a method to track the object. In this, we first define the while loop to keep on running till the escape key is pressed. We read the current frame and capture the frame from webcam. After that, resize the frame. Create a copy of the frame. We will need it later. Convert the color spacer of the frame from RGB to HSV with this line. Create the mask based on predefined thresholds. Check if the user selected the region with these lines. Next, extract the regions of interest from the HSV image as well as the mask. Compute the histogram of the region of interest based on these. After that, normalize the histogram. Extract the region of interest from the original frame. Compute bitwise, not of the region of interest. This is for display purposes only. And check if the system is in the tracking mode. Compute the histogram back projection. Compute bitwise and between the histogram and the mask. Define termination criteria for the tracker. Apply the CAMShift algorithm to the back projected histogram and draw an ellipse around the object and display it. If the user presses the escape key, then exit the loop using break statement. Once you exit the loop, make sure that all the windows are closed properly. Then define the main function and start tracking. Run the code. You will see a window showing the live video from the webcam. Take an object, hold it in your hand, and then draw a rectangle around it. Once you draw the rectangle, make sure to move the mouse pointer away from the final position. The image will look something like this. Once the selection is done, move the mouse pointer to a different position to lock the rectangle. This event will start the tracking process. Let's move the object around to see if it's still being tracked. Looks like it's working well. You can move the object around to see how it's getting tracked in real time. Great! We performed object tracking successfully. In the next video, we will understand optical flow-based tracking.